Hello and welcome to another Portworx demo. My name is Bhavin Shah, and in this demonstration, we are going to talk about how you can deploy a Kafka cluster using Portworx Data Services on a Red Hat OpenShift Kubernetes cluster. Kafka is just one of the different data services that PDS supports out of the box, and you can deploy Kafka on any number of Kubernetes distributions that PDS supports. Today, we are just going to be talking about how you can do it on top of an OpenShift cluster. With PDS, there are a couple of different ways to deploy Kafka. You can deploy it using the built-in RAF mechanism for consensus, or you can deploy it with an external Zookeeper instance as well. In this demo, let's take the complicated way around and deploy a Kafka instance with a backend Zookeeper instance. So let's start by deploying our Zookeeper cluster. Right now we support one version of Zookeeper, which is 3.6.3, and let's just give it a name. So we'll call it zk-demo, and let's select the OpenShift cluster as our target cluster. Once we select the cluster, PDS automatically gives us a list of different namespaces that are available to deploy this specific data service. So I've deployed a few data service-demo namespaces. So for example, I'll deploy Zookeeper in the Zookeeper-demo namespace, and I'll leave the application configuration template to default. This means that it sets a runtime variable for that Zookeeper deployment and allows it to all. I can also have a custom application configuration template, or an administrator can create new application configuration templates that are passed to Zookeeper deployment at runtime. Next, you can select the size of your Zookeeper instance. So you can have small, medium, and large, and this translates to the pod quotas and limits that are set for CPU, memory, and the size of persistent volume that gets deployed for your Zookeeper pod. Let's just select small because this is a demo. And at this point, we only allow 3 nodes per Zookeeper deployment, and you can't increase the number of nodes, can't decrease it. Since this is just used for Kafka, we want the Zookeeper cluster to be a highly available and resilient cluster as well. From a storage perspective, you can select the different options that are available to you. We'll keep it simple. Select a storage option that provisions an XFS-based file system with a replication factor of 2. Once we are happy with all the different configuration parameters, we can hit deploy, and PDS basically talks to your OpenShift cluster and initiates the Zookeeper cluster deployment. You can monitor the deployment using the PDS user interface, or you can also go to your CLI session that has access to your OpenShift cluster and monitor the deployment from the CLI interface as well. So let's do a kubectl get all in the Zookeeper namespace to look at all the different resources that are being deployed by PDS for us. So you can see that our Zookeeper cluster basically translated into a stateful set object with 3 replicas, which match the number of replicas that we had in the UI. Each of these replicas are being deployed as a pod, and then we have a few service objects. We can also monitor the persistent volumes in the Zookeeper-demo namespace, and here you can see the different persistent volumes that will be provisioned for each pod. Let's see how the pods are doing. So we can just do a kubectl get pods in the Zookeeper-demo namespace, and here you can see all the 3 pods for our Zookeeper cluster are up and running. So at this point, our prereq is ready to go. Let's just use that as the consensus mechanism for our Kafka cluster. So to do that, we need a couple of things. We'll need the connection details. So let's just select any one of these. And then we'll also need to copy the password. So to deploy a Kafka cluster, let's just navigate to a new instance of open up a new tab with PDS, select Kafka from the database or data service catalog that's available. And then in this, you can select different versions of Kafka that are available. 3.0.1, 3.1.1, and 3.2.0 are the 3 versions that are supported today. Let's just select the latest and greatest, and then we'll give our Kafka cluster a name. We'll just call it Kafka-cluster. The same deployment workflow works for all different data services for PDS. So once you give it a name, let's select the destination cluster or the target cluster. Let's select OpenShift-cluster. And then similarly, how we deployed Zookeeper, we'll select the Kafka-demo namespace for our Kafka deployment. We'll select additional configurations from an application configuration perspective. So since we are using Zookeeper in this deployment, let's select small heap with external Zookeeper. And this is where we provide those additional details. This is where we'll paste our connection string for our Zookeeper instance that was deployed earlier in this demo. And let's go back and copy the password, right? So let's go to the Zookeeper install deployment, copy the password, and then come back to the Kafka deployment, enter the password right here. You can select the resource setting, again, the quota and the limit for individual Kafka broker that will be deployed. So 1 to 2 vCPUs, 2 gigs to 4 gigs of memory, and 100 gig persistent volume. I want 3 Kafka brokers in my cluster, so I'll select number of nodes to be 3, and I'll keep the storage options to XFS with a replication factor of 2. I can hit deploy at this point, and PDS or Portworx Data Services will initiate the deployment of my Kafka cluster on my Red Hat OpenShift cluster. Similar to how we monitored the Zookeeper deployment from the UI and the CLI, let's go back to the CLI session. And instead of looking at the Zookeeper-demo namespace, let's look at all the resources in the Kafka-demo namespace. Here you can see it's a similar setup where we have a stateful set object with a replica count set to the number of replicas we entered in the UI and a pod deployed for each replica count. Let's look at the persistent volumes in the Kafka-demo namespace as well. You can see that our persistent volumes are also getting created as the pods are coming online. If you clear out this, and then if we just do a kubectl get pods in the Kafka-demo namespace, let's just put a watch command on it. You'll see that almost all of our pods are up and running. And with that, it just took a few minutes for our Kafka cluster to be provisioned on Red Hat OpenShift. Let's go back to the UI and refresh the page. As you can see, we have our 3 nodes that are almost up and running. We are configuring something inside the Kafka cluster, so it still says deploying. Within a few seconds, this should change to just running. And just like that, we have a Kafka cluster that's fully running. We have for consensus, we are using a Zookeeper instance that was also deployed using Portworx Data Services in a highly available manner with 3 replicas. If I want to add more brokers, I can easily do that by changing the number of nodes in my Kafka cluster and increasing the number of Kafka brokers I want in my cluster. I can also go ahead and monitor my application level metrics or my database level metrics using the PDS UI. Since I don't have an application that's actively using this instance, I don't see any activity right now, but you can monitor not just the file system level details, so things like read and write throughput, read and write latency, file system usage. You can also monitor your application level details like total bytes in and out, total and failed producer request, consumer fetches, and so on and so forth. These are application levels metrics that are up-leveled and displayed using the PDS portal itself. So you don't have to switch contexts and go to a different monitoring tool to get Kafka level metrics and use the PDS UI for your Kubernetes or storage level metrics. You get the whole package from just the PDS UI. So that's how easy it is to deploy a Kafka backed with a Zookeeper cluster using Portworx Data Services on a Red Hat OpenShift cluster. That's it for this demo. Thank you for watching.